so here there are two functions. f1 is sine square x and f2 is 1 minus cos 2x. So here we use the method of Wronskian to check that whether it is it makes a linear combination of independent functions or not. So what we do, Wronskian, two functions, how much derivatives? 2 minus 1, first derivative, only first derivative you have to check for this. Wronskian is w of f1 f2 equals to sine square x 1 minus cos 2x and its first derivative. Sine square has derivative 2 sine x and its derivative is sine derivative is cos x. 1 minus cos 2x, 1 has derivative 0 and minus cos 2x has derivative minus, cos has derivative minus sine, so minus sine 2x and 2, so that becomes plus 2 sine 2x. Alright, okay, now we take the determinant and we solve it. Sine square x, cross multiply to cross 2 sine 2x minus 1 minus cos 2x into 2 sine x cos x, that is equal to 2 sine square x. Sine 2x is basically, okay, I am writing it like this, sine 2x, 2 sine x cos x means the identity, I am using the identity here, 2 sine square x sine 2x minus sine 2x, I multiply it with this minus minus plus cos 2x sine 2x. I take it sine 2x is common. Okay, 2 sine square x minus 1 plus cos 2x. Now I am using the identity of cos 2x and that is cos square minus sine square x. Here I am writing the identity. Identity is cos 2x equals to cos square x minus sine square x. So I am replacing here the identity. Sine 2x equals to 2 sine square x minus 1 cos square x minus sine square x. Okay, so sine 2x, 2 sine square x minus x sine square x, this and this, what it becomes? Sine square x plus cos square x minus 1. So what does this identity becomes? Sine 2x, this becomes 1, sine square x plus cos square x is 1, 1 minus 1 equals to 0. Oh, that means its determinant is equal to 0. So that is not linearly independent. That means it is, these two functions are linearly dependent functions, right? Okay, next example. Next example is, there are two functions. f1 is e to the power m1x and f2 is e to the power m2x. So two functions, that means n minus 1 1 first order derivative. So Wronskian of f1 f2 is equal to first function e to the power m1x, second function e to the power m2x, and this condition is also given that m1 is not equal to m2. So first derivative of this is power to that, and its first derivative is, so you have to take its determinant. So 2 cross 2 has a very easy determinant, e to the power m1 plus base is same, so powers are added, minus m1 e to the power m1 plus m2 into x, so that becomes m2 minus m1 into x, and you see that m1 is not equal to m2, so this combination can never be equal to 0. I know this combination for any value of m1 m2, because m1 and m2 can never be equal, so that combination can never be equal to 0 due to this. If it is not equal, so e to the power any constant is a constant, and m1 m2 are also constants, that doesn't make it 0, so that means it is not equal to 0. So what are these? These are linearly independent functions, right? So these are linearly independent functions. All right, so I hope that you understand the concept of this linear combinations and independence and dependence. And also one more thing, if you have 2 or 3 functions, you can use the authentic method, that is Wronskian. But if you have more than 3 functions, like 4 functions, 5 functions, so it is difficult to make to find out its derivative and then find out the determinant is a very hectic one. So what you have to do, you just first of all try the hit and trial method by guessing the constants, and if you cannot guess the constants, then you move forward and you do the Wronskian thing. So I hope that you understand this linear independence and dependent functions or combinations.